Welcome everyone. The question that is shown on the screen, it is a question number 21 of the set 2 question paper of the physics 2025 CBSE question paper. In a young double slit experiment with monochromatic light of wavelength 600 nanometer, the slit separation of 2 millimeter fringes are observed on the screen at some distance. Calculate the change in fringe width if the screen is moved towards the slit by 10 centimeter. So let us draw the arrangement first. What is the YDSE arrangements or the Young's double slit arrangements? So these are the two slits S1 and S2. These two slits actually acts as a coherent sources. Okay, and the separation between them, between the two slits, is, we can say, this is 2D. Okay, and the waves which are coming out from that, okay, which are mutually coherent with each other, that are superposed on each other and forming the interference pattern on the screen, and the distance between the slit and the screen is capital D. Okay, and we know that the equispace fringes are formed. The central is the bright one, which is, we can say, the 0th one. After that the first dark is obtained. After that the first bright is obtained. After that the second dark is obtained. After that the second bright is obtained. Similarly, this side also you are getting the same thing. Okay, so equispace fringes are obtained. And if you calculate the fringe width, then the fringe width expression, that is the beta, is lambda multiplied by capital D divided by 2D. Okay, lambda is the wavelength of the light used, capital D is the separation between the slit and the screen, and 2D is the separation between the two coherent sources here. Okay, now try to understand that here the separation between the slits, that is a 2D, it is of the order of, I am writing down here, it is of the order of millimeter. Okay, but the D, which is a separation between the slit and the screen, that is of the order of meter. Okay, so if you try to assume, that is the, if you want to do the capital D divided by 2D, that ratio is of the order of 10 to the power 3 or 1000. Okay, so this condition need to be maintained here. So what is said there, when it is 600 nanometer wavelength light is used, that is the 600 into 10 to the power minus 9 meter wavelength light is used here, then capital D is the separation between the slit and the screen. Okay, and at that time the value of the 2D is 2 into 2 millimeter, so 2 into 10 to the power minus 3 meter. So if I just find it out, the beta, that is the fringe width, in terms of capital D, obviously you don't know what is capital D, so I am finding out that value in terms of capital D. So obviously this 2 and this thing cancels out and it will becomes 300. So this will become 300 multiplied by 10 to the power minus 9 plus 3. So it will become 300 into 10 to the power minus 6 D meter. So that is the fringe width now. Now what will happen if the screen is moved towards the slit by 10 centimeter? Now if I take another color, let us say this color. So this is now the position of the screen. Okay, and the separation between the two positions is of the order of 10 centimeter. 10 centimeter means 10 divided by 100 meter. So this is of the order of 0.1 meter, you can say. Okay, this is of the order of 0.1 meter, you can say. Now if I try to find it out, what is beta prime is, now lambda is not changed, wavelength is not changed, it remains the same. Okay, capital D is now changed by D minus of 0.1. okay, because it is shifted by 10 centimeter, that is 0.1 meter. Okay, so 2d is there, it is same. So lambda by 2d we have already calculated, that is it comes 300 into 10 to the power minus 6. If you put the values again, you will get the same thing, but here is now d minus 0.1 meter. Okay, calculate the change in the fringe width if the screen is moved towards the slit by 10 centimeter. Obviously d is in the numerator of the expression of the fringe width. So if the d has decreased, obviously we can say beta prime is less than that of beta. So if I now try to find it out, what is the change in the fringe width, that is beta minus of beta prime. So beta is 300 into 10 to the power minus 6 multiplied by d minus beta prime 300 into 10 to the power minus 6 minus of d minus of 0.1. So if I subtract this, obviously 300 into 10 to the power minus 6, if I take this thing as a common, that will be d minus of 0.1, the term within the bracket. Okay, so it is 300 into 10 to the power minus 6 minus 6. So obviously d minus, just see how beautifully this capital D cancels out here. Okay, so d cancels out, so this will become 300 into 10 to the power minus 6 multiplied by 0.1. So 0.1 into 300 is 30. It is 30. So 30 into 10 to the power minus 6 meter. So it is, we can say that is 30 micrometer. Okay, so the fringe width is changed by micrometer, 30 micrometer. If you shift the screen towards the direction of the slit by 10 centimeter in this particular arrangement. So see how the competency based question has asked here. They have not told calculate the fringe width. In the set 1 they have asked one questions. We have already find it out in the previous videos. You will see that is, it is basically about the ratio of the two fringe width. One wavelength of light used, another wavelength of light used. So it is not the ratio. Now it is said the capital D is decreased. What is the change in the fringe width? And you have to find it out, and it is of the order of several micrometer. So the answer is 30 micrometer here. Thank you all of you.